Section 5.1, what we're going to learn about is matrix addition and scalar multiplication, right? So whenever you're talking about functions in general, you want to learn how to add them, subtract them, multiply them, divide them if possible, which it is possible with regular functions. We cannot divide matrices, okay? We cannot divide matrices, but we can multiply by scalar multiples. So this section, we're going to learn how to add, subtract, and multiply matrices by scalar multiples. These operations are used in the study of game theory. So let's start out with a definition here. Let me change the color. Okay, an M by N matrix A is a rectangular array of real numbers with M rows and N columns. So we say the size, remember we talked about the size of a matrix before? The size of the matrix is M by N, so it's rows by columns. M and N are what we call the dimensions. They are the dimensions of the matrix, and the numbers that appear in the matrix are called its entries. Called the entries. We typically use capital letters for the names of matrices, for example, capital A, capital B, capital C. Okay? So, based on what we've discussed so far, what is the size of the following matrices? So remember, an M by N matrix, A, is a rectangular array of real numbers with M rows and N columns. So we say it has size M by N. What's the size of the matrix A? Yes?
2 by 3.
2 by 3, good, because it has 2 rows, 3 columns. You got it. So that's a 2 by 3. What about B?
2 by 2.
Good, because it has 2 rows, 2 columns. And what about the matrix here in C?
4 by 2.
Good, 4 by 2. So it's a 4 by 2 matrix. Very good. Okay? So let's have another definition. If I and J are numbers, then the ith row and jth column of the matrix A is called the ijth entry. It's called the ijth entry of A. So it just tells you where to find it, right? So if you're in row 2, column 3, it's the 2 third entry. Okay? Tells you where to find it. So we usually write that entry as little a sub ij or capital A sub ij. Okay? So with this matrix A equals by row 2, 0, 1, 33, negative 22, and 0, what is the A, 1, 2 entry? The 1, 2 means what?
Is it 0?
It's 0. Good. Because it's asking, what does 1, 2 mean? What does the subscript 1, 2 mean?
First row, second column.
Good. First row, second column. So this 0 here. First row, second column right here. What's A2, 3?
0.
0. Good. Random. What's A2, 1?
33.
Good. Good. So it just tells you where to go in the matrix. Okay? Helps you navigate.
So the first one is always.
So in general, the M by N matrix A has its entries labeled as follows. Now this is just the general form, okay? This is just the general form. So you'll see A11, first row, first column, A12, A13, out to A1N, right? Because it has N columns. Then the second row would be what? You tell me.
A21,
Mm-hmm.
A22, and A23.
Out to? What's the last one? Bless you.
Oh, A2N.
A2N, good. And then we go down. The 3 dots indicates that you have stuff in between. So then we end with the mth row, so a M1, a M2, a M3, out to a Mn. Okay? So those are your entries in general for matrix A. Okay? Another definition? Okay, 2 matrices are what we say equal. They are equal if they have the same size and if their corresponding entries are equal. So you have to have 2 things. They have to have the same size and their entries have to be the same. A matrix that has only 1 column is called a column matrix. Or it's called a column vector. Either one. Okay, so for example, you could have A is equal to this matrix here. What is the size?
1, 2.
Nope. You said 1, 2, but remember the size is always given by the, what comes first?
Oh, it's 2, 1.
2 by 1. You say 2 by 1. Rows by columns. The rows by the column. So this is an example of a column vector or a column matrix. Okay? There's only 1 column. Okay? Guess what a matrix that only has 1 row is called? What's that called?
A matrix.
Well, think about the previous one. It's a matrix, yes. But what kind? A row matrix or a row vector? Good. It's a row matrix or a row vector. It's called a row matrix or a row vector. Okay? So, for example, you could have this one with these entries. What's the size of this matrix?
1 by 5.
Good. So 1 by 5. Has 1 row, 5 columns. 1, 2, 3, 4, 5. 5 columns. Good. Now we're going to go through an example where we have to solve for x, y, z, and w. So we have this, what size is this matrix? 2 by 2, good. We have this 2 by 2 matrix. It's equal to this 2 by 2 matrix. How can we go about solving for x, y, z, and w? So remember, for 2 matrices to be equal, they have to have the same size. They being these matrices, they both have the size 2 by 2, right? And then you have to have their entries are the same. So that means that x minus y has to be 0. X minus z has to be 0. Y minus w has to be 0, and w has to be 6. Okay? So we get x minus y equals 0, which implies x equals y. Then we have x minus z equals 0, which implies what? X equals z, good. Then you have y minus w is equal to 0, which implies what?
Y equals to W.
Good. And then you have w is equal to 6. It is what it is. Okay? So since w is equal to 6, then y equals w, so that means y is also equal to 6. Then you have x is equal to y here. So x is also, and then you have x is equal to z. But what do you know? X equals 6. So z is equal to 6.
Wait, with X, Y, and Z.
All right. So if A and B are n by n matrices, so if they have the same size, then the sum of A plus B, or the sum A plus B, is the n by n matrix where each entry is the sum of the corresponding entries A and B. So in order for you to find the sum of two matrices, they have to have the same size, and then you add the respective entries to find out what the sum is. Okay? So let's go through an example, or couple. Didn't I? Yes, I was like, something's not right. Okay, so here we want to find the sum of these matrices. So you have A, what size is this matrix?
2 by 3.
Do you want me to write the sizes down?
Yeah.
So it's a 2 by 3. B,
2 by 3.
C,
2 by 3.
okay. That doesn't mean a superscript here. Let me erase that so you won't think it. It's a 2 by 2. Can we find the sum A plus B?
Yeah.
Why can we find it?
It's the same size.
Right, they have the same size. They have the same size, that's the first thing we check. So we can add the entries. So A plus B is equal to 4 plus 1. We're adding the respective entries, right? So the 1, 1 entry of A is 4, the 1, 1 entry of B is 1. So we have 4 plus 1, the next one's going to be 0 plus 1. What's the next one? 5 plus 1. Tell me what the second row is going to be.
-1 plus 3.
Mm-hmm.
3 plus 5. 2 plus 7.
You got it. Then notice that this is a 2 by 3 matrix as well. It should be. Okay? So then, what do you get when you simplify?
5, 1, 6, 2, 8, 9.
Good, that's it. That's your final answer. Very good. That's the sum. Find A plus C.
Oh, it's the same, it's different.
So what does that mean?
You can't.
That's right, right. It's not defined. Very good. It's not defined because they're different sizes. Very good. A scalar is a real number. A scalar is a real number. A scalar is a real number. If R is a scalar and A is a matrix, then the scalar multiple, little r times A, is the matrix where each entry in A is multiplied by R. So if I said find R times A plus B, you would take, if R was 3, you multiply each entry by 3. That's what that would mean, okay? Notice that negative A is the same thing as negative 1 times A. So A minus B, when you're subtracting, is the same thing as A plus negative 1 times B. Okay? Now, let A be equal to this 2 by 3 matrix, and B be equal to this 2 by 3 matrix. Compute 2 times B. Compute A minus 2 times B. Would you like a minute?
Mm-hmm.
Okay.
Is it 2, 2, 2? And then
So hold on, 2B would be equal, right, how about that? That would be equal to 2 times the matrix B, which is 1, 1, 1, 3, 5, 7. So, what would you get now?
2, 2, 2, and then 6, 10, 14.
Does everyone agree?
Yes.
Yes, that is correct. Good. Now, to find A minus 2B, can we subtract those? Yes, because they have the same size. They're both what size?
2 by 3.
Good. So then you would have 4, 0, 5. I'm just writing it down. Negative 1, 3, 2. Minus 2, 2, 2. 6, 10, 14. What would that be equal to? How would you find the 1, 1 entry here?
4 minus 2.
Good. You would have 4 minus 2. Do we need to write that down, or can we just write it? Do you need me to write 4 minus 2, or do you want to just write that it's 2?
No, it's okay.
Yeah,
Okay.
right.
So you get 2. Then you get 0 minus 2 is?
Negative 2,
5 minus 2 is?
3,
3. Then you have negative 1 minus 6 is?
negative 7,
Negative 7. Continue.
negative 7, and then negative 12.
You got it. Very good. Very good. And of course you can box your entries. What questions do you have? Okay. All right. So if a matrix, before we go through that, wait a minute, I skipped it. Have a matrix whose entries are all 0. It's going to be called what kind of matrix?
Wait, I have a question.
I have an answer. Good. So a matrix whose entries are all zeros is called a 0 matrix. So if I wanted the 3 by 4 0 matrix, how many rows should it have? 3. How many columns? 4. And what are the entries? Zeros. You got it. That's it. That's a 0 matrix. That's an example. Now let's learn a new concept. If A is an m by n matrix, then its transpose is the n by m matrix obtained by writing its columns as rows. So the ith column of the original matrix becomes the ith row of the transpose. So notice that your rows become your columns and your columns become your rows in your transpose. Okay? The transpose of the matrix A is denoted A super T. A super T is reserved for A transpose. That's the notation. Now let's look at some examples. If you want to just pay attention first, I'll give you time to write. So, A is what size?
3 by 2.
It's a 3 by 2 matrix. So its transpose should be what size?
3 by 2.
Nope.
2 by 3.
See, it says A is an m by n.
Right, yeah.
So the transpose should be
2 by
n by m. So as you said, good. This will be a 2 by 3. So that's the size. We don't need to write the size, but we're just writing extra information to help us along the way. So the transpose has 2 rows and 3 columns. So the first row is going to become our first column. So we're going to have 0, negative 1. Our second row is going to become our second column. And then our third row is going to become our third column. So that's the transpose. So if A is the 3 by 2 matrix, given A transpose is that 2 by 3 matrix there. Okay? What kind of matrix did I give you here in example 10?
1 by 3.
A 1 by 3 matrix is also called a, what kind of matrix? A row matrix, good. So you have a 1 by 3 matrix, so what is the transpose of it?
3 by 1.
A 3 by 1. What kind of matrix is that going to be?
A row matrix, or a, column matrix.
A column matrix, good, a column matrix. What are the entries?
1, 1, 2.
And 2, you got it. That's it. Good. Very good. What questions do you have? Okay, so then the back, last page, is just properties of matrix addition, scalar multiplication, and transposition. So suppose A, B, and C are any m by m matrices, and suppose that the script 0 is the 0 m by n matrix. Then the following properties hold. A plus B plus C is the same thing as A plus B plus C. That's associative law. A plus B is the same thing as B plus A. A plus 0, the 0 matrix, is the 0 matrix plus A equals A. That's the additive identity. A plus negative A, if you have a matrix and then you add the opposite of it, you get the 0 matrix, and vice versa. If you take a scalar times the sum of two matrices, that's equal to the sum of the scalar multiples, C times A plus C times B. C plus D, so here C is a scalar, D is also a scalar. C plus D times A is equal to C times A plus D times A. 1 times A is equal to A. 0 times A is equal to the 0 matrix. A plus B transpose is equal to A transpose plus B transpose. C times A transpose is equal to C times A transpose. And the transpose of A transpose, you get your matrix back. So you just get A. So it's important for you to know all of these properties because you're going to apply them. Okay? What questions do you have? Yes. To understand number 11, remember that whenever you take the transpose of a matrix, so suppose you start out, suppose A is an m by n matrix. Ignore this for a second and look at this transpose. What's the size of this A transpose on the inside? You start out with A as m by n. What's the size of A transpose?
Is it A or 1?
Listen to my question. I'm asking you what's the size. A is a size m by n matrix. So what's the size of A transpose?
Is it by M?
N by m. Very good. It's an m by m matrix. Now if you take the transpose of an m by m matrix, what's the transpose of that? What's the size?
M by N.
You got your original matrix back. That's why the transpose of A transpose is A. You got it?
Yep.
What other questions do you have? Okay, excellent. So that's matrix addition and scalar multiplication.